Yes, so good morning, and I'm making this recording for students who are learning photogrammetry. Digital photogrammetry is the way to go, and I want you to learn how to do the basic. The basic is to take images and then be able to process those imageries and then those photographs, and then extract some data from it, from these photographs. I extract coordinates. That's the final goal of every geospatial expert. Every person doing geomatics, your target, your goal is to map the world. Are you okay? All right. And so how do we use photos to do that? We've already learned the theories, okay? And we take advantage of stereo photogrammetry in order to do this. Okay. All right. So the e-foto software allows us to practice with this image, learn how to load the image, basically learn how to load the photos. And most software work like that. All right, so I'll stop sharing and I'll share my entire screen. It's better if I do that. Okay, then I can show everything. All right, so eFoto's website allows you to ignore all these things that no, my website. I'm just busy also playing Christmas carols for my baby. So we do all of that. Okay, we do family and we do work. And so we need to come here. And when you get to this website, you have the images, sample images. Then you have sample project files that allow you to work, but you need to actually do it yourself. Are you okay? If you don't do it yourself, you won't be able to make any progress. Okay, so first and foremost, find a folder where you download your images. In this folder, you find I have 3 overlapping photographs. And these overlapping photographs also these photographs come with the camera calibration certificate. And so the camera calibration certificate contains the info on the camera that was used and even the aircraft, the platform that was used to capture the imagery. Okay. All right, so if I can zoom out a little bit, you can see that this is even in Portuguese. Okay, it's always been, but then you can see flying, focal length 153 millimeters right there. Portuguese is not that, difficult a language. Anyway, you can see distancia focal nominalis, nominal focal length. Okay, all right. So as I tell, there's a number, a serial number in here, Siri, and you can see clearly, you can actually understand Portuguese easily. Are you okay? All right. So you can see the number of photos, okay? 17 photos been taken, all right? And you can see other values that you can relate to, okay? All right. Now, we need to also look out for the format, 23 centimeters by 23 centimeters. Is that okay? If I get my notation on, this is actually right there. Okay, if you can see it. All right. So with all that information, you can setting all the values that you need. Okay. All right. So I'll just go downwards. If I just stop annotating, then I can move the page. Okay, then I need to also clean the annotation. This is what I just don't like about, this annotating using Zoom. It's always not convenient, but of course, if you go down, let's ignore that box. Let's just go down there. You see that we also have all the other parameters, coefficient of radial lens distortion. Remember, we talked about this in class, okay? And so this is actually, there's a function that allows you, a radial lens distortion can be corrected using a function. Are you okay? All right, or the error is distributed according to a function. And that function is actually a polynomial, all right? And that polynomial also has the coefficients. Okay, so when you look in the handouts, you find that. All right, so all that is provided in the camera calibration certificate, okay? The centering error is also stated here. So in this first file, we find all this information. And in the second file, we also find the fiducial coordinates. If you understand what fiducial coordinates are, they allow you to start with the set up a coordinate system. Okay. Fiducial coordinate systems relate to photo coordinate systems. Okay. And then also we'll also talk about a comparison coordinate system. But here, fiducial coordinate system is just nothing more than it relating to the dimension of the photograph. For example, we have 23 centimeter format, so half of that, okay, so 230 millimeters, and then half of that it becomes your S coordinate, if you like. Fiducial coordinate system can be referenced if you look at the diagram here, all right, to the center or to the bottom right. Which one do you think we are using right now? If you look at the diagram, you can see clearly that point. We are using the center. Are you okay? We as the origin of the coordinate system, which makes points one lie on the zero y coordinates. Are you okay? Because on the x-axis, y is 0. So we need to think this basic idea and let it help us. Okay. Of course, we can have this, curve that relates to the radial symmetrical error. Are you okay? Radial lens error. Okay, guys, forgive me, but this video has to be done quickly. And so, yeah, we go on and then look at our e-foto software. Okay. And then in the software, hope I could just clean this up quickly. Annotation that I didn't get options for cleaning up the annotation. That's a shame. All right, I think there are tools here that can be used. Okay, so eraser is here. All right, so I just took that off. Great. On this e-foto software, there are a lot of options here: interior orientation, spatial resection, photo triangulation, and all the way DSM extraction. This is where it gets fun, but a lot of students don't get there. But you can take it and make it your project topic. Okay, how to use e-foto to really generate a DSM. So, but in the beginning, you need to understand how the software works. The software really works in a very interesting way. The whole software kind of can be opened up. Can you imagine that using Notepad, and then you can see all the settings that you have in the software. What I say is that interior orientation is the first step, but you need to load the images first. All right. So if you take a blank project, that will be, you have to set up your sensor. So I'm not going to start a blank project, which is forcing me to do. You need to provide the information on the project, who owns it, blah, 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 the terrain, where we indicate how the terrain is, the location of the terrain, etc. Okay. It has the coordinates also in there, longitude and latitude. The sensor, okay. You need to also tell us which aircraft that was used, blah, blah, blah. If it's a drone, I don't know how you're going to manage it, but this is to explain to us the basic. So later on, the other software, okay, that can also be used. We'll talk about that maybe in another session. Okay, so we need to feed in all the, coordinates for the principal point, etc., camera configuration certificate, etc. All right, for the sensor. Okay, the sensor is like the camera, so the lens, okay, the focal length for the lens, etc. Okay, principal point 00. Then we can also enter all our, data on the K1, K0. So you pull all that from the camera calibration certificates. All right. If you follow the tutorial, which most of you probably might have done already. All right. Then you come to flight. Then you have to also put in your overlaps, okay, your side laps and your forelaps. You should know this if you are doing photogrammetry 2 and you're doing stereo analysis. You understand what overlaps are. Just put in the data. Nominal flight altitude above sea level, you put that in nominal, okay, and then the producer's name, blah blah blah. Then your images, you need to now load the images into this. Okay, so you have to now figure out where your images are and then just load them in. This is something every student should learn. You need to do this. I mean, it's IT really at this point. It's not what you call it, photogrammetry anymore, I can say. So we've loaded one, the 17 photo. So photo 17, 18 has been loaded. So there's one more that we need to add on to this. Okay. So we need to now bring that in as well. Okay. So just to follow that with the tutorial and then to go in a certain fashion, you need to be able to see the images that you just loaded in. Let's just go step by step. Let's take one image. This is the error that you get with this software. So the workaround when you cannot see the image you just loaded is to save the file, okay? I'll use it as it is, but I'll save it, okay? And we take note of where we saving it, okay? So you go to my computer, try to get to documents, my documents, or desktop. Let's put in desktop. And then let's call it test e-foto project PRJ. So give it a name that makes sense, one, and then put it on your desktop. And then when you've done that, you can close this, go to your desktop. And then whilst you're there, you're seeing Tintin right there. I just love Tintin going up. You right click and open it with Notepad. Then at this stage, you need to set the relative path, replace the relative path with the actual absolute path to the pictures. This is a workaround. I'm sure this is not like ideal, but this is the only workaround for you to see the image, the photograph. Is that okay? All right, so we have photo 16, 17, and 18. All right, so now let's look for where these are. All right, so there's a file path, and then we need to point it right there so that we can pick the images. Is that okay? All right. So I've already opened one that I'll show you to make our life easy. I don't want to now experiment, but I'll show you this this file type, which is a test file. It's just like if a file that keeps only text only, no pictures. So if you were doing Word, you would have seen pictures. You can't put pictures, just text. But this is a very important file type. Are you okay? The TST file. Here you can see that we have our relative paths, which is the reason why we cannot see the images. Okay. So for photo 17, all right, we are going to actually point it to exactly where the software can find the files. And when we do that, we will see the images in the software when we open it up, which is like a long process, but well, as long as, so here I have the images, I've copied it. So you click right up here and you press Control C, copy, and then you paste it here in the area where you want to have it. Okay, so this keeps popping off. That's wrong. Okay. All right, so just as simple as that, and then that solves that error problem. I've even I've written off something on it on I think LinkedIn. Okay, so maybe I can share that with you, but we didn't have to go through all this. That's it. That's interesting. I close the file, I save it, go to my desktop. Now, when I open this, the images should become visible. And in a similar way, I can actually add a third photo. Okay. We open up the file, okay, right? And having opened the file, if you set everything up as we said with Notepad, you realize that if you look for images, okay, maybe the third one, you see that there's everything has been arranged in what we call a marker file, where everything has been, there are tags. Are you okay? So images contain is cascading elements. Are you okay? All right. That points to the information that we have already put into the software. So we are really behind the software. It's like we are doing a bit of programming. So the first image is actually located here. So if you said this is an absolute path, that should make sure the image shows, okay? And the same with the second image, 17, okay? So 16, 17, and then 18, okay? So just look for file path and replace it. All right. If you create your project, if you follow it to this point, then you can do that. All right. So now we go back and then we can open the file. And then this time the images will show up ready for interior orientation. And the rest is just so easy, isn't it? So all we need to do is just to view image, then we can see the image. Okay. Right. What it also means that if you press interior orientation, we can work on interior orientation for photo 16. This is where a lot of people don't get to. You get the errors coming up. All right. Okay. So with that out of the way, now remember that we need to actually tell the computer where the fiducial marks are. So as you can see, 1, 2, 3, 4 matches with our camera calibration certificate. Okay, which is actually on the second image. Okay, so on this one, you can see 1, 2, 3, 4. Okay, so right to left, top to bottom. I mean, a way to do this, but that's what you see in there. Now, the box here is going to do a transformation between pixel coordinates and the coordinates that will be supplying. Are you okay? And these coordinates should be such that 1, so 1, 2, and then if you can actually resize this somehow. If you cannot resize, we can go down. 3, okay, and then 4. So the 4 points are in there. Okay. And then once you indicate in here, in fact, what you can do is that you can zoom to places, okay? You can zoom to the photo and then mark these points, all right? You can mark them. It's a free software, and this is the challenge with free software. Sometimes you cannot really get it as you want it. If you wanted to delete, a point in here, you need to figure out a way to do it. Okay. This is the button that does the interior orientation. This is the report. This means we're done. Are you okay with the interior orientation process? But what it really entails is identifying these 4 points. Okay. And then you can now run it and then get some result. Of course, this is very statistical, so you need to be able to interpret it. Okay. So XA, this is the unknown, and this is the covariance matrix. Okay. Covariance matrix of the XA, which is the unknowns. Are you okay? All right, great. So you need to bring in your knowledge of survey adjustment, okay, and statistical analysis, and then you'll be just fine. All right, and so is this good or is it not? The values should be small enough. That's the main thing. All right, so there you go. Very small values for the residuals is good. Okay. Observation matrix, these are the values that we put in there. Are you okay? XA will be unknowns. Okay. Then you have your observations, and then you have your residuals. Okay. All right. So it's statistics really. So with that, we can accept the results, and if we accept it, then we can say we are done. Then it goes in the software. Okay. And that's interior orientation done. Then you can carry on and do your spatial resection. Okay. And we all know what spatial resection is about. That's what GPS uses, determining the position of an object by observing from different points. Are you okay? From different locations. That's what happens when we're in photogrammetry. When we do that, we are just looking at different exposure stations and their coordinates and being able to, determine the coordinates of another point on the ground. Okay. All right. So we can also start the spatial resection, and then we have an image. Do you want to save changes? Yes, we want to. Then we can now go ahead and identify some ground control points in here, going by the tutorial, always. Okay, so the tutorial itself is in there somewhere. It should be in one of these folders. Okay, I'll just look for it. Go in here. Let me see, uni, go to tutorial. So in T orientation, you could have just followed this one all the way. Okay, so all that I talked about, identifying the fiducial mark, it's a small marking that you need to look out for the black area. Yeah, for the student, this is just to help you to understand. Okay, all right. And then there you go, all the way. You get the results. Okay, and then you can interpret your results. Make sure you have small errors, not huge errors. Of course, it depends also on the precision, the accuracy of the work, accuracy standards. Okay, all right. You can look at the spatial resection quickly, and then you can see that, like I said, you will need to have some controls, okay, in there, right? So here we identify some ground controls, okay? And then with that, we can now set it into the software. Okay, that's basically what. So we need these controls, these control points, which is will be provided for you. Okay, that you can now work it out. Determine the coordinates, okay, of any other point of interest. Of course, that's our goal, okay? So you pick point one, you tell the computer, okay, point one is here, and these are the coordinates, okay? Which I think you don't have to really type it in. You can pick it straight from the software, all right? So as you go, you can just say you're done when you're ready. So let's assume you pick the point. Okay. Okay, so I think it takes a while and it's crashed. It has it crashed or not? Put it back in. Yeah, it did crash. Okay, did it not? Yeah, it did. Okay, so of course, depends on your computer. You can actually have better processing of the data for you. Okay, spatial resection. Okay. So I just wanted to measure and I pick a point somewhere in the could be intersection of a road, etc. And then you wait for it. Okay. But let's go back to tutorial and look at, okay, keeps crashing, but of course, this is not a normal behavior. So um, we can follow the tutorial and then get it. Okay, can just get it. Right. So spatial resection. Of course, T orientation by spatial resection. What's the T orientation? We've already learned it. There are 6 elements. The X naught, Y naught, Z naught. These are the coordinates, the ground coordinates of the aircraft. I told you about that. All right. So we are trying to use ground control to determine that, of course, and then we can determine the other coordinates. T orientation by spatial resection. Okay. All right. So that will be it. I just wanted to use this video to explain to you what the possibilities, what you could have done. Okay. And so that's basically it. All right, we'll end it here. And then I'll see if I need to make another video. Okay. For now, this is basically how this e-foto software works. The tutorial is there. Follow it, you get some results. Then you can do some analysis, think through and see whether it's good enough for you. Okay, so let me know how you feel about this. Bye-bye. And your observation should be more than the number of the minimum that you need. So there should be some redundancy. Then you can apply the least squares, okay, algorithm. All right. So